Philippines. Hello, Region 1. Aloha sa Caribbean learners. Airing live from the Manila, the blue capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SEO/SEC learner, where passion is the key, learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SEO/SEC learner.
It's science time again. It's science time again. Oh, come and join the class. It's science time again. Hello, adorable young scientists. Are you ready for another exciting learning adventure in this captivating world of science? That's great. So, join me and let's get mesmerized in the beauty and wonders of the world as we engage, explore, experiment, and investigate scientific concepts and information. I am your science teacher for today, Teacher Rose, right here, live at Carlos and Carlin Network, where learners learn best. So, to begin our lesson, please prepare your self-learning module, Quarter 3, Module 4, together with your paper and pen. And our lesson for today is electric circuit. At the end of the lesson, we expect that you will be able to infer the conditions necessary to make a bulb light up. And here we are. So to begin, let's have a pretest first, entitled Complete Me. Write the missing letter to complete the word being described in each number. So let us start for number 1. It is composed of interconnected electrical components which allow electric current to flow in a complete path. So, what do you think is the answer? Okay, you may write your answer in the comment section or in your paper. So, the answer is electric circuit. Next, number 2. It is a kind of circuit that results when the knob is switched on and the metals are connected with each other so electricity flows. What do you think is the answer? Again, you may write your answer in the comment section. The answer is closed circuit. Another clap for you. Number 3. It is a kind of circuit that results when the knob is switched off. The metals are disconnected, so electricity does not flow. What do you think is the kind of circuit? We have open circuit. Number 4. It happens when exposed wires touch each other. What is that circuit? The answer is short circuit. And for number 5, it supplies the power, maybe a generator, a battery, or a solar cell. What do you think is the answer? So, the answer is power source. Okay. Next, let's have a short recap of our previous lesson. Last time, we have studied about conductors and insulator. So, what is the difference between the two? So, let us answer this one. These are the materials or substances which allow electricity to flow through them. So, what is your answer, dear learners? The answer is conductor. Next, these are the materials or substances which resist or don't allow the current to flow through them. So, what is your answer? The answer is insulator. This time, you're going to classify the objects if conductor or an insulator. So, put them on the proper column. You can make two columns. For the first column, it is for conductor. For the second column, it is for insulator. So, here are the objects that you are going to classify. We have wood, metal spoon, pencil, gold bars, tin can, notebook, silver ring, rubber band, iron nail, and cloth. So, I'll give you 20 seconds to write your answer. Okay, so the time is up. So, let us reveal the answers. So, for conductor, we have metal spoon, gold bars, tin can, silver ring, and iron nail. Remember that these are the materials that allow electricity to flow through. For insulator, we have wood, pencil, notebook, rubber band, and cloth. So again, these are the materials that resist the electricity to flow through. So, did you get all the correct answers? So great job for you, young scientists. This time, we're going to look for words, or we have this word search. Find 5 words inside the search word puzzle. So the clue is, these are the things or gadgets that we use in our daily life. You can make it vertically, horizontally, diagonally, or in any directions. So here is the word search. So I will give you 10 seconds to look for those words. Again, the clue is, these are the gadgets that we use in our daily life. And time is up. Have you looked all the 5 answers? Okay, so let us reveal those words. We have computer, cell phone, television from right to left. We have laptop and radio. So here are those words. We have television, laptop, computer, cell phone, and radio. So what are these things for? Are they important in our daily life? Yes, of course. Most especially at this pandemic, we use these gadgets for learning. Most especially for online learning. And such as this television, if you have that smart TV, you can use or you can watch the CCN. And of course, we also had the radio that we have this radio-based instruction. But how do these gadgets work? How can we use them? Of course, we can use these gadgets using electricity. So, how does electricity flow to our appliances? What are the components of this complete path? So today, we are going to have an experiment on how does electricity flows. So, we are going to make or construct a circuit. Here are the materials that we need. 1.5 voltage AA battery, small bulb, 220 centimeter copper wire, small switch, electrical tape, screwdriver, and wire stripper. So we are going to construct an electric circuit like this. So I have prepared a video for you to watch. So please listen very carefully because after that I have some questions for you.
Hello dear learners, today we are going to make an electric circuit. So what are the things that we need? We need a battery, bulb with a receptacle, a small switch, and a copper wire.
So the first step is to connect all the materials. So we need the copper wire to connect it with the battery. So let's use 2 batteries so that the bulb will be brighter. Then use a tape, an electrical tape. And then let us connect it to the bulb. So be careful in using the screwdriver. And if you're going to do this at home, make sure that you will ask for help for your mother or father or any elders at home. And then the switch. Another wire for the bulb. So now let us try. Okay, so the bulb lights up because there is a complete path of electricity, and that circuit is called closed circuit.
But if we're going to disconnect the switch to the bulb like this, okay, so there is a gap or there is no complete path of electricity. So this kind of circuit is open circuit. Okay, so let us put it back. Okay, so let us remember that the switch controls the flow of electricity. It can connect or disconnect the flow of electricity. So when we turn on the switch, the kind of circuit is closed circuit because there is a complete path of electricity. And when we turn off the switch, because it will disconnect the flow of electricity, the bulb will not light up because there is an incomplete path of electricity. And this kind of circuit is open circuit.
Okay, so have you watched the video? Did you understand it? So, this time, let's answer the following questions. Number 1. What are the components of electric circuit that we made? Okay, so I'll give you 5 seconds to answer. You may write it on the comment section. Okay, so the answer is, we have the bulb, wire, battery, and switch. Next. What happened to the bulb after you connected the switch to the wires, and why? So again, I'll give you 5 seconds to answer the question. Okay, so of course the bulb lights up because there is a complete path of electricity. And number 3, how did you know that electricity flow in the circuit? What happened to the bulb? Okay, so the bulb lights up because there is a complete path of electricity. Next, number 4. What happened to the bulb after we disconnected the switch to the wires? Why? Okay, I'll give you 5 seconds to answer again. So if you noticed in the video, I disconnected the switch to the wires. So what happened to the bulb? So the bulb did not light up because there is a gap or incomplete path of electricity. And number 5, what are the 2 circuits discussed in the video? Again, I'll give you 5 seconds to write your answer. Okay, so the 2 circuits introduced were closed circuit and open circuit. And for the last question, what is the difference between the 2 circuits? Between closed circuit and open circuit. So I'll give you 10 seconds to answer it. To think of your answer. Okay, so time is up. For closed circuit, the path of electricity is complete. In open circuit, there is a gap or no complete path of electricity. In closed circuit, electric current flows, while in open circuit, electricity does not flow. And in closed circuit, the switch is on, while in open circuit, the switch is off. So to elaborate more of our lesson about electric circuit, let's have this. What is an electric circuit? An electric circuit is composed of interconnected electrical components. These components form a complete path of an electric circuit. What are the parts of an electric circuit? Number one, we have the power source. The source of energy to move the electrons, maybe a dry cell, a battery, a generator, or a solar cell. So here are the examples of power source. Number two, we have the connector, the wire or other conductors that link all parts of the circuit and create a path when current flows. So we have here the connector or the wire, and usually these are conductors. Number three is the load. A load is an output device that uses electricity, such as the light bulb, appliances, computers, and gadgets. So here are the example of load. Our appliances, computer, and the bulb. Number four is the switch. The switch controls the flow of electricity. It can connect or disconnect the path of electric current. So again, what are the parts of an electric circuit? We have the load, the power source, the connector or the wire, and the switch. What are the two continuity of an electric circuit? So we have discussed there, we have closed circuit and open circuit. First, what is closed circuit? A closed circuit makes the bulb light up because the path of electricity is complete. In closed circuit, electric current flows through the connecting wires from the power source to the device, example the bulb, then back to the source again. So looking at the picture, the flow of electricity comes from the battery, going to the bulb, and then going back to the battery again. Number two, open circuit, which is switched off. Electricity does not flow in this kind of circuit because there is a gap or no complete path from one end of the circuit to the other end. If it is an open circuit, an electrical device does not work. So again, if you turn on the switch, the kind of circuit is closed circuit. If you turn off the switch, the kind of circuit is open circuit. So take a look at these pictures. What are these? These are faulty wirings. And is it safe? Of course not, because it may cause fire. So what do we call this? This is a short circuit. Short circuits occur when a low resistance path not suited to carry electricity receives a high volume electrical current. In simpler terms, short circuits happen when hot wire touches a conductive object if it is not supposed to. So, look at the wire, it sparks. That is a short circuit. So how can we avoid these situations? So here are some of the safety measures or safety rules in using electricity. Number 1, pull the plug, not the wire. Number 2, never use wet outlets or those dipped into the water. It may cause electric shock. Number 3, when you are not using your appliances, turn them off. So are you doing this at home? If you are going outside, please make sure that your appliances are turned off. And in this way, we can also save electricity. Number 4, never stick or insert a metal or any object into an electric outlet. Okay, so the 4th there is a conductor of electricity. So, a big no for that. Most especially to all children and young learners out there. Don't do this. Number 5, do not place electric appliances near water. It can cause electrocution or electric shock. Number 6, stay away from electric power lines when flying a kite. Do not climb on power posts too. And do not plug too many appliances into an outlet. So that is what we call an octopus wiring. So don't do that. Number 8, do not touch light, switches, or plugs of appliances when your hands are wet or when you are standing on a wet surface. So, dry your hands first before plugging or turning on the lights. Number 9, call a qualified electrician if you want to repair your faulty wiring or broken appliances. So do not repair them by yourselves. Number 10, cover electrical outlets with plastic cups, especially if there are children in your home, because there is a possibility that they would insert something on the outlet. Okay, so how about these fuses and circuit breakers? Fuses and circuit breakers are devices that ensure safety when faults and problems in a circuit arise. So make sure that we have fuse or circuit breakers in our home. A fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential component is a metal wire or strip that melts when too much current flows through it, thereby stopping or interrupting the current. How about the circuit breaker? Here it is. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. And here we are. So, this time we're going to answer some activities. Label the parts of a simple DC electric circuit shown below. So, I'll give you 5 seconds to think of those parts. Okay, Okay, so time is up. So what are the parts of the electric circuit? We have first the load, the power source, the connector or the wire, and the switch. Did you get all the correct answers, young learners? Okay, that's good. And know me more. Match the concepts in column A with description in column B. So here are the choices. Number 1, it is a circuit where electricity cannot flow. What is your answer? So, if the electricity does not flow, it is called open circuit. It is letter E. Number 2, composed of interconnected electrical components. So, what is the answer? Okay, we have letter B. It is circuit. Number 3, it is a source of energy. So, what did we use in our experiment as a source of energy? We used battery. So, it is letter A. Number 4, circuit where electricity flows freely. Because there is a complete path of electricity. That is letter C, closed circuit. And number 5, connects the light bulb and the battery. What do you call that? It is letter F, wire. Okay, yay, you made it. Did you make it? That's great. So I'll give you 3 smiling stars. And now, let's check what have you learned. So, you have to answer the concept map. So, what are the components of the electric circuit? So, we have 4 components. What are the 2 continuity of circuit? And what are the 2 devices that we need to prevent faulty wirings or dangers using electricity? So I'll give you 10 seconds to answer and think for the answers. Okay, so time is up. So let's have this. What are the components of electric circuit? We have the load or the bulb, power source, connector, and switch. What are the continuity of circuit? We have the closed circuit, wherein there is a complete path of electricity. So, and the switch is on. And open circuit. There is a gap or no complete path of electricity. And that is when the switch is off. And now, what are the 2 devices? We have the fuse and the circuit breaker. Okay. So again, let's do this. For safety measures, write a check mark if it shows safety measures in using electricity and cross out if it is not. So let's have this number 1. Fix bare electric wires. Is it right or wrong? So of course, it is right. Next. Number 2. Okay, is that right? Octopus wiring or many appliances were plugged in only one outlet. Is it good? Is it right or wrong? It is wrong. Next. Number 3. Wet hands in plugging. So is it correct or wrong? Of course, that is wrong. You have to dry your hands first. Number 4. Never stick a metal in an electric outlet. Is that right or wrong? The answer is, it is right. It is correct. And number 5. Flying kite near electric power lines. Of course, is it right or wrong, dear learners? What is your answer? It is wrong. So, do not fly kites near electric power lines. That is dangerous. And let's have this assess for success. Choose the letter of the correct answer. Number 1. Which of these is a source of electrical energy? A. Battery. B. Light bulb. C. Switch. Letter D. Wire. So, write your answer. The answer is letter A. Battery. Number 2. Which of these controls the flow of electric current? A. Battery. B. Light bulb. C. Switch. Letter D. Wire. Okay, so the answer is letter C. Switch. It controls the flow of electric current. Number 3. When the switch is on, the electric circuit is blank. Letter A, is it closed? Letter B, open. Letter C, short. Letter D, B, and C. So the answer is closed circuit. Number 4. How does the electric current flow in a circuit? Is it A, from battery to light bulb and back to battery? B, from the battery to the battery and back to the light bulb? C, from the switch to the light bulb? Letter D, both A and B. So, what is your answer? Okay, so the answer is letter A. From battery to light bulb and then back to the battery again. Number 5. Which of the following measures can prevent fire caused by electricity? A. Touch a switch with dry hands. B. Avoid walking under low dangling wires. C. Have a regular inspection of electrical cords. D. Never stick a metal in an electric outlet. Actually, all those choices are things that we should do to prevent or to be safe using electricity. But the question is, how are you going to prevent fire caused by electricity? So the answer is letter C. Have a regular inspection of electrical cords. Okay, so great job for you, young scientists. Because you made all the activities. And now, let's have your homework. You are going to create or construct your own circuit. So this is a reminder. Make a short video while performing the activity and send it in the group chat. Do the activity with adult supervision. Do not insert wires in an electrical outlet and be careful in handling materials, especially the bulb. And here it is. So, just like this that I made. Okay, so, ayan. Does it light? Okay, so that's it. Here are the materials that we need. And now, okay, for our references, we have of course the self-learning module, Quarter 3, Module 4, Electric Circuit, and a textbook, Science Beyond Borders. No copyright infringement intended and credits to the rightful owner. Okay, so thank you for listening. So we started it with a song, then let's end it with a song. So, it's time to say goodbye. It's time to say goodbye. Thank you for listening. It's time to say goodbye. Okay, so I am Rosemarie Gil C. Arboleda from Pangpang Elementary School. Thank you and good day.
Good day, Philippines. Hello, Region 1. Aloha, Central Linian learners. Airing live from the Mango Blue capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SCC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SCC learner.